Welcome back to Part 6 of Section 1.1, Displaying Distributions with Graphs. We're going to go back to doing the histogram and see how we can find out where the cut point should be and how to do that. So we're going to take a look at the Altria group. First of all, I pulled up the data and I am going to enable the commands. And the data, if you look at it, it's right there. And if I want to put data in ascending order, I can do that. So I'm going to go into data. I want to sort it. I have to select the data that I want to sort. I want to sort it by itself. And then I'm going to put it in the C2 of this particular worksheet. Hit OK. And there's the sorted data. And I can see what the smallest data value is, and I can scroll up and see what the largest data value is. So the range of my data goes from 3.01 to 10.96. So I calculate, so I make a reasonable min and max, so my range is between 3 and 11. That range would include the real data. So I've got this range that I'll make up, so I'm in whole numbers, 3 to 11. So my range is 8, 11 minus 3. Now the number of classes, if I want my tick marks to be whole numbers, would have to be some factor of 8. So I could either, let's look at all the factors of 8. 1 and 8, 2 and 4, those are all the factors of 8. So I could either have 1 column, 2 column, 4 columns, or 8 columns. And we just said that you have to have between 2 and 20 classes or bins or bars on your histogram. So the only number that would be feasible would be 8. So I would go into here and I'd say, okay, if I want to graph this and make it a histogram, and I want the daily stock, hit OK, and I get my graph. And I want it to be whole numbers on the tick marks. So first of all, I have to make my tick marks at the cut points. And I want the number of intervals to be 8. When I do that, I want my positions of my ticks to be at 3, 4, 5, 6, 7, 8, 9, 10, and 11. And now I have the right number of bins with the correct tick marks on there. And that's how you can do this. And of course you change your titles and make it all work very nicely. More as we get into doing mini tabs, we'll see one more example of this, but this is just a quick way to show you that. And most importantly is learning how to read the information off a histogram. So looking at this, this is the alcohol-related traffic fatalities for our states. And it says, first of all, determine the class width. Well, we know to determine the class width, we have to take 2 consecutive lower class limits and subtract them. And since each of the cut points are a lower class limit, we just look at 2 of them that are consecutive. 200 minus 0, that's 200, would be our class width. And to identify the classes, we wouldn't say 0 to 200, 200 to 400. That'd be incorrect. We'd have to say 0 to 199 because there's no such thing as a half death. So you could say that, or you could say 0 to 200, not including 200. That would be another way you could say one of the classes. 200 to 400, not including 400, or 400 to 599, 600 to 799, and so forth. To identify the classes. Which class has the highest frequency? Well, the first class, the 0 to 199 fatalities. If I wanted to do a cut point command for this particular problem, if you were looking at a cut point command, what the cut point command is you say cut point, you give the minimum data value and the maximum data value that you make up that's reasonable. So in that last Altria example, we would have said 3 to 11. In this case, we'd say from 0 to 1800. And then the class width is the next, you do a backslash, and then you put your class width, which we just determined to be 200. So that would be the cut point command. And again, we're not having you learn commands, but it's kind of nice to know how to do that because it also teaches you how to get classes. So, and then you can answer the other 2 problems just by reading the histogram. Now we're going to look at stem and leaf plots. A stem and leaf plot is a great way to take the raw data and make what's like a histogram turned on its side graphical display. So it's an actual graphical display with the data itself being used, where the leaf is the last digit in the number and the stem is all the other digits. And you have to let someone know, like this 17.3, if that's 173, or 17.3. So somewhere you have to let someone know what that data is. So if we look at the raw data up at the upper right corner, and we know that this data is 5.6, so the leaves are the tenths place. And we can now look at the data right here, and we can now say, well, 5.6 is the smallest data value and 18.0 is the largest. With stem and leaves, you always put the stems from the smallest number to the largest, and the leaves, again, from the smallest to the largest. You include all zeros, you include all repeats. It's really literally everything, all the data points should be seen on there. And as you can see, if I flip this on its side, it'd be a histogram. Now the advantage is it contains more information than a histogram because you actually see the raw data, and it's a quick way to sort the data. Disadvantage would be that it can only be used for smaller data sets. Histograms are more flexible also in the choices of classes. So we're going to do this example, and what I'd like for you to do is stop the tape here and go on and make a stem and leaf with this data. It's sorted at the bottom. And this is what it should look like when you get finished. Now I'm going to change the data up a little bit and see what happens if it's changed just a tiny bit. So with this being my new data, now it's time to do a new stem and leaf. Now the 7.8 will remain, and then there'll be 8.1, 3, 6, 8. Well, now I have to put the repeats in here. I have to put the other 8 and the 8. And this time there are no 9s. And I don't get rid of the 9 row. I keep the 9 there, and I show that there are no numbers in there. It's sort of like a histogram without a bar at a particular interval. And then I'd have my 10.2 and my 11.0 and 7. So that's how you would do a stem and leaf. Some things that could happen. If my data is given to the hundreds place, Minitab, when it does a stem and leaf, will truncate the data. In other words, 0.05 will become 0.0. It will not do the normal rounding rules. So what you need to do is you need to round your raw data correctly and then do the stem and leaf, because as you can see, the stem and leaf plots would be different. Now what happens if we have data like this, that we would only have 4 classes because my stems go from 1 to 4? Well, we do what would be called a split stem. So we go from 1 to 4 and then 5 to 9. So we split it because as you can see in figure 12, there's not enough columns there. We need, remember what they said, we need between 5 and 20. So we need more than 4. So we double that by splitting it the way that we have. This is a side-by-side comparison, and these are great because you can compare two things very quickly. And in here you can see which of our 2 fast food restaurants gives us more choices for less fatty sandwiches, and you can see that McDonald's wins that. So the modified stem and leaf plots where you can do the side-by-side are wonderful for comparison's sake. And the last thing we want to look at is the dot plot. It's not in the book, but it's a really fast way to look at the data once again. Those dots really represent a data point, and you can see that they again correspond to what a histogram would look like. So dot plot is a very wonderful way to do analysis work, to look, in other words, to look at the data very quickly. Examining the distribution of quantitative data, the overall pattern of the graph, deviations from that overall pattern, shape of the data, center of the data, spread of the data, and outliers. So now it's going to be time to take a look at some of the different shapes. This is the uniform distribution where all the values are the same. The number of times we see each variable value is the same. This is our bell-shaped or symmetric distribution, and the model that models this would be that right there. Here's another type of symmetric, a mound shape. Right skewed data, it tapers off to the right. That's what we call right skewed. And that would be the model of the right skewed data. This is left skewed data, the raw data. It tapers off to the left. And the function or the model that we could use to model that would look like that right there. Well, this ends it for part 6 of section 1.1, and we've got one more to go. Thanks.